All right, thanks everybody. This is our last talk of the event. We've got Wasiq to take us home talking about neutral atoms and quantum computing. So take it away.
Thank you, Will. Wow. So I'm the last person standing between food and networking. And I will try not to use the full 15 minutes. I know it's been a long day and just fantastic presentations, one after the other. So let me make you a few promises. Number one, I'll try to wrap up in 15 minutes. Number two, I won't talk in a lot of detail about tech. I'll just talk about business and other elements. And number three, I'll just try to make it as real as possible in terms of what I've seen from my experience. So brief background about myself. So Pasqal is one of the world's leading quantum computing companies. We are a late-stage company based out of Paris, France. We have raised about 125 million euros to date, a team of about 230 people. We have operations all over the world. And we provide not just quantum computing, we provide the full stack. And I'll talk a bit more about that. My background, I'm a physicist by training. I did multiple startups, had 3 exits. I was a VC for a while. Then I was at Google, then I was at Amazon. I ran pretty large businesses there, and now I'm doing this. But one of the things that I've brought to this, or what we collectively brought to this, is how do we actually build a business versus build something which is fit for a lab? And that's been a thought that's been permeating Pasqal from its first days. There we go. Okay, so let me start with some of the co-founders. George, Elaine, Antoine. For people who know the neutral atom space, Antoine Brouet is a legendary figure. Elaine Aspect won a Nobel Prize in 2022 in quantum mechanics, so he's very well known. But what's really remarkable is that this is one of Elaine's saying, there are no fundamental limitations. When there are no fundamental physical limitations, engineers find a path. And this is something that is so true that sometimes we have physics or theoretical calculations that say something can happen or cannot happen, and then engineers make it happen. So, and this has been part of the DNA of the company from day one. This practical thinking and getting your hands dirty and never taking no for an answer, and really thinking that if we hit a brick wall, or if we think that something is not possible, go deeper. And the second that's really attractive about Pasqal is, now I'm a Silicon Valley guy. The US startups are really good at marketing, so they will talk a lot about what they can do, and which is great, it's a huge strength. But one of the things that was really attractive about Pasqal is the company would do much more than it would say. So they just kept grinding away at solving problems. And that is really the kind of perseverance you need to build something and to go against what people think is not possible. This is the wonderful team. It has grown quite a bit since this picture. The vision is to deliver state-of-the-art quantum computing. And it does not call out what kind of quantum computing, it is quantum computing. And later I would argue that quantum computing is one of the triads of computing that we have to think about. It's along with Gen AI, along with traditional HPC, this is the third leg, the third pillar. Very large opportunity. There's a sustainability angle here. What do we sell? Let's start with our quantum computer. This is the quantum processing unit. They run at room temperature, no cryogenics required. I'll talk about how they run. Their power requirement is really low. So we heard earlier that the human brain uses 20 watts. In the GPU world, we regularly talk about megawatts of power consumption. Our state-of-the-art quantum computer uses few kilowatts and does not require cryogenics. It's a major advantage. The other big thing is that everything from day one has been designed with an industrial mindset. We designed and built for scale from day one, regardless of how many computers we had. And this has been a big advantage for us. The way the system works is we use neutral atoms, rubidium specifically. So we talked about, superconducting qubits and so on and so forth. We use a rubidium atom as the qubit. Every rubidium atom is like any other rubidium atom. We trap them using lasers, we excite them using lasers, we entangle them using lasers. And this is a very scalable process. So we recently demonstrated more than 1,103 rubidium atoms that we could control in our system. So that's a 1,000-qubit system. Now it's very scalable for multiple reasons, because you can literally represent in three-dimensional space the problem you're trying to solve. So our quantum computers can work in analog mode or digital mode. And in an analog mode, for example, we can arrange these rubidium atoms and we can entangle them in 3D space, and the Hamiltonian or the energy function of the whole system solves the problem. And this is something that we have demonstrated multiple times for very important business problems, and I'll talk about that a bit. So very simple approach, but simplicity is very important, because this then allows us to build our machines in such a way that they're actually scalable, they're industrial machines. And then we can ship them to, and we can expect the same performance from them every time. Very important thing. But we also provide a full stack solution. So it starts off with the hardware at the bottom. Then we provide the algorithms and the software layer, the control layer, and the solution layer on top. We provide the full stack. And we've been working with multiple partners to provide the full stack. I talked a bit about this. Some of the major investors, Temasek, Aramco, and some of the leading investors out of Europe. Another thing that's been at the heart of the company is deliver what you promise. So here what we have is what we promised in our Series B and where we are today. So I talked about the 1,000+ trapped atoms. We wanted to scale the company. We have more than 30 corporate customers and clients at this point. We have 3 in operation on-premises QPUs. We have 1 which is accessible through the cloud. And these have all been certified to be enterprise grade ready by BCG recently. And we have expanded to multiple locations worldwide. Now, we talked about different types of quantum computers and qubits. But neutral atoms have been really interesting because they've been the dark horse in this race. And nobody really expected neutral atoms to do anything until in the last few years, a lot of new discoveries and breakthroughs have really pushed this to the very edge in terms of the leading contenders. So in terms of the number of qubits, we compete very favorably with everybody else out there. Very important part is the coherence time for our qubits is measured in seconds. The peak coherence time for a neutral atom qubit is 40 seconds, which is a big deal. Our gate fidelities are very high, connectivity is very high, and so on. So BCG identified us as one of the leading players. But this is the slide I really wanted to talk about a little bit. They also compared us to the other approaches in quantum computing, and they looked at, have we built a lab grade? Yes. Have we built industry grade? Yes. Have we delivered, installed, and set up the first on-prem? Yes. In a different country? Yes, where we are on the way to do that, and so on and so forth. But these are the manufacturing scale-up steps that are necessary for us to build a company and a business that delivers the same performance, just like servers do today. And that's been part of our journey so far. I talked a bit about this. Our business model is you can buy directly QPUs from us, or you can get access to our QPUs through the cloud. And then, of course, the software, the platform, the solutions, the algorithms, and the libraries that are all available. The embedded part of this is we don't do this alone. It takes a village to do it. So we work with a lot of partners. Some of those partners are from the companies that have been speakers before. So we create an ecosystem with local and quantum company partners to develop and deliver our solutions. Multiple companies, some very well known, all with each and every one of them, we are solving specific problems that are mission critical to them, and I'll talk about that for a second in about a minute. So we are looking to expand our team. So if you're interested in this, please come talk to me, and we have opportunities in all of our locations worldwide, so we can talk more about that. I'm going to skip this, but actually, let me not skip this. There was a lot of conversation earlier about quantum versus Gen AI versus classical computation. So here's my view, and maybe it's slightly controversial. All classical computation, which is Turing machines, they will basically solve in complexity class P. But quantum computation falls in BQP. So by necessity, there are problems that you cannot solve regardless of how powerful your traditional machine is. So that's something to take away. However, quantum computers will give you exponential acceleration in solving problems that fall in complexity class P. So that's a big advantage to start off with. Plus the second one, they will solve problems that you can never solve. Now, of course, Gen AI is very hot these days. Everybody's talking about it. But I have a view on this. The view is, I think we are overestimating what Gen AI can do. And the reason for that is that the combinatorics of the really interesting problems that we need to solve are really high. So the number of chemical compounds, not including polymers, that can exist is a very large number, 10 to the 63. But if you look at the amount of proteins that can exist just with 400 amino acids, that's 10 raised to the power 500. Now, somebody has to prove that a Gen AI system can actually sample through that possibility space without those training data sets. I think the answer is probably going to be no. But nature, by definition, does quantum computing. When a protein folds or when an amino acid forms, nature does the quantum computation inherently. Because in quantum computation, you get to see all possibilities that can exist. So for that reason, I believe that these are not substitutes of each other. They're overlapping compute paradigms. And quantum computing is as much of a pillar moving forward as Gen AI is or traditional HPC is. And we will need all three moving forward. And I think this thesis will play out because we are already seeing the glimmers of it in terms of the work that we are doing with our partners. And this is a very important point because then it's not an either or, it's an and situation. So I'll give you some examples here. But before I get into this, I want to share something which was part of my experience. I don't know if any of you remember the nanotech times from 15 years ago. Doesn't anybody remember that time? Great. Okay, we have a few. So if you go back in time, 15 years ago, there was a lot of interest and enthusiasm and excitement about everything that nanotech could do. But as I look back, decades later, how many of those companies really exist today? I only know two. And how many actually delivered on what they promised to deliver? Only those two, and only a fraction of those. And I think the reason was that people could not make the difference between what is theoretically possible and what is customer provable in real life and scalable. That was the big lesson. And I think a lot of that applies to us also. And this is something for us to just really think about as we go about is how do we go and find real business problems that have economic value for the customer and show that you can solve that problem today. You don't have to solve it by giving a 10x advantage and then go and do it again. That's the basis of business. That's what I've learned so far, and that seems to work. So on the basis of that, the way we are approaching the market is saying, look, we will not go and provide you 100x or 10x. In some areas, which are very large areas, if you give a 1% improvement over the status quo, that's a big deal. In logistics, in network design, typically these improvements are few basis points per year. If you give me 100 basis points, it's a big deal. I'll give you 100 basis points today, I'll give you another 100 basis points next year, and so on and so forth. People are more than happy. And this way you know exactly what is needed and you go solve that problem, you build the entire stack and solution that solves that. And that's exactly how we are going after this. We started our work in designing these networks 3 years ago with a leading telecom in France. And 3 years later, we demonstrated that we can solve the same problem 20 times faster that their high-end HPC systems can do. And then we can push the boundaries on how much more complex we can make the network. And we just keep pushing the boundaries on that. So that's one example. And that's our paradigm of how we go and demonstrate the value of quantum computing today. It's the same thing here, where we are working with a leading bank. This is Credit Agricole on portfolio management, portfolio optimization. It's a financial application. In this case, again, we showed that their state-of-the-art models using very high-end compute was overly complicated compared to our system. We could do it with much fewer classifiers to solve the same problem. These are very important problems. But that is how we have divvied up across different industries, different use cases, materials design, portfolio optimization, toxicity discovery, and so on and so forth across different partners that we have. We have published our roadmap. I won't bore you with all the details. It goes all the way to 10,000 qubits in the next few years. And then, of course, on the digital side as well, we will scale to a very large number of gates. And I'm happy to talk about it after the conversation. Just to wrap up my talk, a couple of recent announcements from our company. So first, we just made an announcement with IBM. And IBM is considered a leader in superconducting qubits. And they consider us a leader in neutral atom, so quantum computing. So we announced that we will be working together where we will create a common interface for customers to interact with our systems. So on the back end, the problem can be parsed partly to the HPC system, to the IBM system, or to our system, so that in totality, the problem is solved. And then, of course, we'll be doing some other work and material discovery together as well. The second is actually a pretty big deal for the industry, is that we just announced that we sold a quantum computer to Aramco. It's the first commercial sale of a system. This is a 200 qubit system. And this, Aramco is an investor, but they're very prudent investors. And this is for real world problems, very business critical problems in terms of reservoirs, optimization, and so on and so forth. So multiple areas over here that we'll be working on. And this is just what a assembled and a disassembled and an assembled quantum computer looks like when it's delivered to a customer. So it's all boxes and crates, but that's how it needs to be. But this is a system that we just shipped to Genchi in France. Long slide here, but basically the company is post-revenue, so we are in 8 digits in terms of the revenue that we have currently, and we are scaling, but we're doing it very methodically, step by step, and focusing on solving business problems. So that's my talk. I hope I did not take the full 15 minutes. Okay, so with that, thank you very much.